All right, I think we can kick it off. And let me officially kick this CDM off. So, hello and welcome everyone to CDM for the month of May. Today we have a light agenda, I would say. We have one topic, and Martin is already here before time, I would say. So, I think I'm going to hand it over to you, Martin.
Hi, I'm Martin Omar. I'm working for IBM. I have recently started working on Ceph within a group that actually tries to bring some Ceph devices, some IBM devices, particularly these are NVMe storage devices produced by IBM into a Ceph deployment. These NVMe devices have the capability to do online compression. So they basically provide a large space, like 22 terabyte of logical blocks, but this is backed by only 9.6 terabyte of physical storage space. So their usage model is very similar to the VDO device that is already supported within Ceph. So the VDO device has the same kind of usage model, and it uses a side channel to report back to basically the top layer of Ceph what the actual usage of physical blocks in the device is, to allow early warning of basically disk full, which is not directly visible from the usage of the logical blocks. In order to support our device, actually I first experimented to put in code to basically just next to the video component into Ceph, but this didn't look right to me because it would just add our device. So I changed the strategy by adding a plug-in system. For this, I basically copied the base structure of the Erasure code plugin system into basically a new plugin system that is basically in a neighboring directory. It is, I call this thing XBlock device, EXTBLKDEV. And it basically loads plugins that have an interface that provides all these side channels that actually the VDO uses to provide physical block utilization up to the Ceph layers. And I took the VDO device and basically created one first plugin to basically demonstrate how this plugin system works. Have a reference implementation, and this allows now us to later add the plugin for FCM device. That's our storage device. The problem is right now the API for our device is still vendor specific, and I'm not allowed to basically put it open. But this plugin approach basically would allow us to basically ship plugin to any kind of customer who uses our device, or even us using the device in our IBM cloud. And later on, I hope that in the very near future, we actually get the green light to open up the interface to our FCM device that allows the access to the physical storage state of the device, so that we can actually put this plugin also in the base Ceph database. So yeah, that's basically it. So I split the pull request into two commits. One is the actual plug-in system with the VDO device, or VDO device plug-in, and the other one is actually a feature that we need for our specific device, which is a commit that enables the setting of the Keycaps flag in Linux. This Keycaps flags maintains the capability set across set UID system calls. So when you basically switch from root to the Ceph user, you can keep the permitted capability set that would allow later on a plug-in device or any device drivers to activate capabilities that it needs. So for example, we need NVMe pass-through our basically query commands. They are log queries. For that, we need sysadmin capabilities. And our plugin then just flips in the effective capability set the sysadmin on when we read the state and then turns it back off so that actually no other part of the Ceph code can access this capability unless it's explicitly aware of that. This setting of the Keycaps flag is also gated by a configuration flag that is by default false. So you would need to actually enable that flag in order to keep this capability set active across setuid calls. I think that's basically it. So the structure of the other commit that actually implements the actual plugin system consists out of course, some CMake. So I added a subdirectory where the actual plugin system is. The subdirectory is xblock device. So I had to add CMake files, add in the base CMake of the source directory, the inclusion of that directory. I had to change the Ceph spec to get these xblock devices also deployed when the packaging is done. What else? The kernel device is actually the part that calls this interface. So I basically changed there the calls to the VDO components by the calls across the registered plugins in the plugin system. So the plugin system provides basically a plugin registry via configuration strings. A set of plugins can be specified that gets preloaded on Ceph's actually OSD start time. And then when a device is opened, we go over the set of plugins and find the plugin that actually can control that device. And that is then registered with this kernel device structure. And then later on, when utilizations are queried, we call the interface of the plugin. Yep, that is that part. What else do we have? Then there's the plugin system itself, the plugins, and the preload of the plugins in global init. And I think that's basically it.
Cool. Yeah, I guess a little bit of background for everybody who's there on the call. We discussed this briefly at the CDS session for Rados, and everybody thought it was a good idea. But I think that at that time, your PR wasn't structured in this way. I think it's very well structured at the moment for review. So it's kind of a follow-up of that. And at the moment, have you been able to? I know there's this the existing video as your current user of the plugin, right? So it's the first plugin that you use. Have you been able to test it at any level?
Actually, I have not tested the video. I tested our FCM device. We've run extensive tests with the FCM, but not the video, I have to admit. For the video, I really just copied the code out of these video things.
Yeah.
I have not tested it. So I'm actually not aware. I know that the video is a Linux module, but I think it's not a part of the regular distribution. I think it's owned by, I don't know, Red Hat. I think the video technology. I don't know if it's open source and available for everyone.
Yeah, I think I was looking through the original implementation where Sage actually added it, and I was seeing how he tested it, and there are some hints I got from there, but I'm not sure if those are still valid. And this is the PR I'm looking at. This might be a good reference to look at, but I'm not sure all the details still hold true. Anybody else? Yeah, go ahead.
It's owned by Red Hat, and I think they failed to upstream it when Red Hat acquired the company that did this, but it is available. I have no idea how much of a pain it is to get running anywhere else, though.
Yeah, there's a comment in the original PR, but I don't know if that'll work now. Yeah.
Yeah.
And I also don't know if there are any users of this. Do you know, Greg?
In Ceph or a VDO?
No, I mean like the Ceph video implementation that we have. Is anybody using it?
I'm not aware of anyone. I mean, even when they put it in, this is trading off CPU time for better storage efficiency, which is the wrong direction for almost every Ceph deployment. So, you know, the hardware one is a lot more interesting that Martin's group has. Um, I haven't. I'm just skimming through this now. Certainly, the shape of this interface looks right to me. I don't think there's any problem there. I'm a little concerned about the Keycaps, partly just because I'm not real familiar with like the details of how this security model works. But I mean, we stop running as root on purpose and just sort of keeping all our root capabilities.
So
If
yeah,
this bit is set, I don't love.
so the idea of the Keycaps, I mean, is a little bit more complicated. You basically, in order to normally, you don't really use the Keycaps. You set a set of capability flags on an executable. When that one is loaded, and the user itself has a set of capability, then basically the end of that set is what becomes available, and that application at that point needs to be aware of capability and set these individually. The Keycaps basically takes a broad stroke. It's really when you switch from root to something else to keep basically the flag set. You can actually also kill individual flags so that after you switch root, I think that there are more than 30 different flags that affect basically some kind of root capabilities. For example, there's one specific for accessing raw sockets, or so you can do a ping, for example. So there is a fine granularity. The problem is, so I could extend this patch to have more configuration options, so where you could actually specify, hey, I want to keep capabilities, but I want of these 30 plus capabilities only that one to survive the switch. And then it would also only survive basically in this permitted set, which still does not enable you to do system calls. You still have to then do specific capability calls to activate it, put it in the effective set, and then you can use this capability. So there is some, I mean, let's say it this way: if you have a component in your Ceph code that is aware of this capability, it can actually flip them on and abuse them, right? But still, you need to call this function. It has to be intentional. You cannot unintentionally do it. Does it make sense?
Yeah, I'm just, I mean, we're a storage system and our security model is of varying quality. Sort of, we do try and at least respect this one.
Okay. So I don't know if it does make sense if I add more configuration options for the Keycaps to basically further trim down what survives even in the permitted set.
I'm trying to think if there's a good way to make it like user configurable, or if we just want to be like, you know what, like you want this pass through one, and let's just make that the option is to keep the pass through. I'm not sure.
Is there a way to simply specify the capabilities you actually need?
Yes, you can actually specify. So the way it works, the Keycaps basically says the permitted set from the user ID that exists at the point of time when you set the Keycaps will be maintained over the next SUID call, right? But you can flip all of them off. You can never flip them on. You can only flip these effective bits off. There's no way to flip them on.
Right. So I'm saying you should select the exact capabilities you actually need and preserve those.
Yes.
Do not preserve
that's
all
what
of them.
I was asking. Should I basically add another set of options, which would basically precise flag?
Bluntly, there shouldn't be an option to just preserve all caps. The option should be preserve the caps required for this module to work. You should identify what those are, and that's what you should preserve.
Okay.
Yeah, so because it looks like has like you're configuring it based off of the device name and passing in, it looks like config options that are just a string, right, to set up the plugin.
Oh, the plugin has strings, yes.
Right, but I mean like Ceph, like that's just getting passed through to it to do its configuration. So we can just have a function interface that's like, needed capabilities, and then the config option can be preserve capabilities for this plugin.
That was the one of the two commits does. It just doesn't specify the exact capability. It just has one big switch like, yes, we want to keep them, or no, we don't want to keep them across.
Right, but I'm saying, yeah, that's what I'm saying is that we can have Ceph query the plugin for which capabilities it wants and preserve only those capabilities.
We specifically don't want to keep all capabilities. The whole point here is to limit the attack surface of a misbehaving Ceph process, right?
Yeah. But I have to make a disclaimer here. The capability system itself is not that great in the respect that the individual capability that exist have been a patchwork. I don't know if you read about that. They have been added basically on need basis, and all the capability for which not a specific class has been found, they have been all swept into a capability bit that is called sysadmin. So there are several specific ones, like you can access raw sockets. That's a specific capability, but everything that has not this kind of specific designation, the Linux kernel has swept them all up into the sysadmin, and that's actually the one that I need for the pass through.
It still makes sense to disable the ones you don't need, right?
Sorry?
Still makes sense to disable the ones you don't need.
Yes, sure. Makes sense. So, but
that's a fair point.
You made a comment, basically. There are two options to implement it. One, have an option in the option files where you can specify, hey, I need that one, or provide each of the plugins with basically, let's say, a query function where you can return a required bit set, right? That would automate that system. But I don't know.
Yeah.
I think that's the way to do it.
But yeah, I don't know. Still, in the end, the user might not be really aware which can of worm he opened just by pulling in a plugin that suddenly requires to set the system.
Yeah,
and if he
that's true. But at least the module doesn't blanket permit all of them.
Okay.
It's still better than that, right?
Okay.
Yeah, and you need higher level admin permissions to, like cluster administration permissions to enable those plugins and things, and we can put appropriate barriers in front of doing that if they get scary.
Okay, I can do that. This should be not too difficult. Just add a function that returns a set.
Yeah. But
that also actually means that there's a library, that LiftCab's library, that actually manage all of that. That basically can create sets and provide the structure for that and calls the kernel functions. At that point of time, I would actually need the LiftCabs be part of the Ceph dependency set, right? Nobody gets upset if I add one more requirement to Ceph.
I assume it's widely available in distributions, so no.
Okay.
That shouldn't be a problem.
Okay, that's good. Okay. Then, I will add this, the LiftCab, another basically extension of the interface to the plugins, and then a query function, which has to happen before we switch users. Okay, sure, we can do that.
Yeah, I think other than that, I don't really have any big concerns. Obviously, it would be nice to test it, but given that clearly...
I will test it. So if I run into troubles getting the VDO or getting the VDO to run, is there any name you can give me who I can poke or who can
I don't have any name on the top of my head, but I can find out. Okay. If anybody has any contacts, I can find out. But again,
I will just try how far I get, and then
yes,
I will,
perfect. Yeah, that sounds good.
Okay.
Did we really merge the original VDO without any automated tests?
I think the Sage did some testing. That's why I pointed out in the original.
Locally.
The VDO needs the capability needs the VDO plugin in the host kernel activated. So I don't.
Yeah.
Anyway, yeah.
The danger is that this merges, and then you test it once, and then a later mutation to BlueStore causes it to stop working, which no one notices until the next release, and some customer tries to run it on this hardware. So that's why the concern here is about automated testing, not were we literally able to stand it up before the PR merged?
Yeah.
But
Yeah.
that can be practically difficult. So
Yeah,
Oh,
I mean, if the plugin isn't in our repository, then the testing burden has to live with the owners.
So are you running your tests actually on VMs that you basically configure VMs however you need it, and you could configure a video
Yeah.
VM? No?
No, we have bare metal nodes. We don't use VMs.
Okay.
We can run whatever kernel we want though, and we
Yeah.
routinely
Yeah.
install new ones and testing ones.
Okay. Okay.
Let's see here.
Yeah, in any case, I don't think we should stress over that. I guess the next step would be to get some reviews and stuff going. And if you're able to provide more testing details, that'll be great as well
Okay.
to
Sure.
take this forward.
Okay. Sounds good.
Cool. And thank you. Thank you for, and I think this is very structured and the way you presented it, it sounds awesome.
Okay. Thank you.
All right. I think that is the only topic we have for today. Anything else you want to discuss?
Well, I did ask some questions that I mentioned in the replanning session. So my understanding is that, like I pointed out, the video integration is kind of weird in terms of how it looks to the upper layers of the cluster, where it doesn't understand that the space sort of doesn't really exist. And in terms of balancing and stuff, it sounded like that wasn't something you were too worried about for your initial deployment, but are you going to become worried about it? Are you planning to spend more time like extending this as you put it into operation in your data centers, or?
That's a good question. I mean, in theory, it would be nice, for example, to get compression ratios propagated up and display them and so on, but all of this doesn't exist in Ceph, right?
Yeah.
So in that part, it would be a huge endeavor, and I don't know what the return for that is immediately. I mean, of course, if I had a choice, yeah, I would like it to be better integrated, but we will see.
Okay.
I'm not that sure how that was going to pan out.
Yeah, I just, as long as you're aware of those limitations.
Yeah.
With them. Okay, cool.
Cool. Any more questions? If not, I think that's all for today. Thanks, Martin, and
you so
thanks
much.
everybody else for joining. See you next time. Bye.
Thanks all.
Thanks. Bye-bye.